So today we're going to do number 13 from chapter 13, double 13s. So we have two stars going around their center of mass, and it is in a circular orbit, and the velocity is equal to 220 kms over s. So it is easiest now to convert to 2.2 times 10 to the 5 meters a second for that velocity. And the orbital period of each is 14.4 days, which we will have to convert into seconds. And then it says find the mass of each star. So we know that force equals mass times accelerations from Newton's second law, and in class we discussed how, well, it's an elliptical orbit, so we know that there's centripetal acceleration, so mv squared over r, and then the force being applied by gravity is g m, and in this case it's basically going to be m squared because it's not like Earth is involved or the sun's involved. And then we are going to have, and the equation that I'm doing this from is force equals gme little m over r squared, and then so we kind of manipulate that into g, and that's basically gm squared, and then r squared, but in this case our r is gonna be 2r, because it says that the center of mass is midway between them, so you know that it is 2r for the radius. So now we cancel out m's, and then we solve for m. So m is equal to v squared over r, then g is over here, 4r squared is up here, so cancel out 1r, and then, sorry, that's a g, not a 6, and then we have 4v squared over, that as out, 4v squared over the constant g, and then we have r, and we don't really know what to do with r at this point, and that is why it is important that you're given t, the period. So we know that it goes around, so we know velocity is distance times time, so distance equals velocity over time, and we know that each star is going to go in the circle around this, which is the circumference of 2 pi r, equals the velocity, which we do not know, and then t, we're gonna change into the period, so that's big T, and so r equals big VBT over 2 pi. So 4v squared vt over 2 pi g, so little variable changes, and you get v cubed period over pi g, and there's a 2 on top, and plugging in, you need to make sure to change your days into seconds up here, and I already did the kilometers to meters conversion, so you should end up with 1.26 times 10 to the 32 to the 32nd kg, and then it does say that the in the question, for whatever reason, it says for comparison, the mass of our sun is 1.99 times 10 to the 30 kgs. So these two stars are a lot heavier than our star. And that is our final answer.